My task is about how to use the exponential function in real life, so I make my search, then I begin. We use exponential function in many things, like calculating population in city or town. This method will help in saving time and effort. Example, the population of popular town of Smithville in 2003 was estimated to be 35,000 people with an annual rate of increase of about 2.4%. So what's the growth factor for Smithville and the equation to model future growth? Also, we have investing money, which means having certain amount of money and finding a way to double and triple the money for certain year. Example, Marisa invests $300 at a bank that offers 5% compounding annually. So we can find the growth factor for investment and equation to model the growth. We use exponential function to figure out the bacteria growth. Let's take example about bacteria growth. A certain strain of bacteria that's growing in your kitchen counter doubles every 5 minutes, assuming that you start with only one bacteria. How many bacteria could be present at the end of 96 minutes?
So, I got a call from my son who's away at college. He didn't say much, but I could hear the pain in his voice. He needed me. He was homesick, and he needed his mother. Well, I canceled my classes, and I jumped in my car. My students are going to be really upset because they always tell me how much they love my classes, especially the early ones. And this afternoon, they're supposed to get the results from their unknown labs. But my kids come first, right? It's only a 5-hour drive, and at least I know where all the coffee stops are on the way to Chicago. And they're open early. I took care of things. He's okay now. I mean, he still has some bumps in the road, but he's on the way to independence.
Did you see the microbiological concept being illustrated in the back seat of Kelly's car? The coffee cups in Kelly's back seat multiplied in an exponential fashion. Imagine this coffee cup is a bacterium. Through the process of binary fission, 1 cup becomes 2, 2 become 4, 4 become 8, 8 becomes 16, and 16 become 32. If the doubling time of each generation is 1 hour, after 2 hours there are 4 bacteria. After 4 hours there are 16 bacteria, and after 5 hours there are 32. 32 bacteria are cups of coffee, and Kelly made it to her son in Chicago.
Hello, this is task 2 and this is a part of the 3 minutes math challenge which I have to solve the whole task in less than 3 minutes, so let's start. Who wants to be a millionaire? Well, I do. Imagine that we're sitting in a math class and there's that famous millionaire, his name is Bill Jobs. Do you know him? Me neither. He offers you the job of lifetime. You'd only need to work for 1 month, which is 30 days, and you could become a millionaire. He offers you 3 payment options. Option 1 says that you earn $1 million evenly distributed over the 30-day period. So day 30 you have $1 million. To know for each day we have to divide 1 million over 30, which is $33,333.3333. So summation of the 30 days is 1 million. Let's talk about the slope. Slope is 0, so no increase or decrease in salary. Salary is fixed. Equation can be modeled by y equals this number. And here is the linear regression calculations. And here's the graph. Option 2 says that you earn $3,000 the first day, then for each following day an additional $3,000 will be added to the previous day's salary. So for each day we have to add $3,000 of the previous day's salary. And summation is this number. Equation can be modeled by y equals 3000x, x represents days. Slope increases $3,000 each day, and this is the regression graph. And here comes option 3. You earn once in the first day, 2 cents the second, and double your salary for 30 days. Like seriously, we're talking about cents, not dollars. We used some math and it was amazing. We converted the summation into dollars, and it was $10,737,418.23. Man, you're already a millionaire. And this is the regression graph. I can see that this graph does not follow a linear model, it's an exponential one. There is a question that says which option will you choose, explain. To know that, write the summation of each option, and the perfect option was 3, which was the greatest, assuming that we have 12 months. So we multiplied 12 by the summation of option 3 and we got this number. Who's ready to be a millionaire?
Task 3 talks about the world's population and how can we use exponential growth functions to calculate it.
It took hundreds of thousands of years for the world population to hit 1 billion. In comparison, it took only 123 more years to reach 2 billion, and merely 33 years to hit 3 billion. Currently, the world population increases by 1 billion people every 13 years. Every second, an average of 4.2 people are born and 1.8 people die. That's a net gain of 2.4 people per second. Today, the population totals almost 7 billion. By 2025, it is estimated to reach 8 billion. By 2050, there will be 2.5 billion more people on Earth than there are today. That's an increase equal to the entire world population in 1950.
Using the link provided in the project paper, I found the world's population and the average annual growth rate in my birth year, 1998. Using this formula, I found the world's population in this year, 2014. Using this information, I wrote the exponential growth function, where A equals the population after certain years, P equals the world's population in my birth year, R equals the average growth rate, and T equals my age now, which is 16. Then, I went to a World Population Clock website and found the actual population now. The reason why the actual world population is greater than what I found is that the equation didn't consider twins and triplets in counting.
Watch